Awesome. So welcome to today's session on the June exam revision. We're going to look through, have a whirlwind romance with a whole bunch or series of concepts. Just stop me if you have any questions, pop them into the chat function or the Q&A function, and let's see if we can help you a little bit with it. So on the plan for today, lots of different concepts that were covered in both term 1 and term 2. And then you'll see Euclidean geometry's got a little star and it's highlighted in blue because Euclidean geometry is such a massive topic and it's not one that I love. So what I've done is I've actually linked you to the YouTube video of a webinar we did last year with Kevin Smith of the Handbook and Study Guide series. And then we are planning another one in September of this year with Kevin again for Euclidean geometry. So keep an eye out for that one as well. But if you do want to go watch the Euclidean geometry, because it was quite heavily requested, then you can do that here. All right, if you don't know about Sharpies, Sharpies is a maths teacher reward program. So you can earn points. So if you are a Sharpie, you will earn points for attending today's webinar. And of course, if you share Sharpies with your friends once you have signed up yourself, then you will also get points for doing that. There's lots of other ways to earn points, and you can go visit Sharpies and take a look at that. The reason that I'm saying you can go click on these links is because on Monday, I will also send you a PDF version of this presentation as well. So you can go and take a look through and click on any of these highlighted blue links if you need to. So some of the resources and downloads that we love at Maths at Sharp, of course, is you can download the simulator for the calculator that we're going to use today for your laptop. GeoGebra is wonderful. Someone mentioned last night that if you register with GeoGebra, you get all sorts of access to all sorts of different resources and help. So that's a wonderful resource to have and to use. Then of course Maths at Sharp, if you're not familiar, has got grade 8 to 12 maths and math literacy and a couple of technical maths worksheets as well. eClassroom is for the littlies. And then I've started my own personal blog called themathsjourney.com, which will also have maths worksheets on it. And you are welcome to start browsing through as I build up content for you there as well. And then, of course, today we're going to be using the Sharp 535 where necessary. So this one is blue, but they also have red or white buttons as well. Same calculator, just a different dress. Then some important buttons that you need to know is the mode button, which changes the different modes, your BS button, which is your backspace button, your change button, which changes the answer, and of course your equals button, which will give you the answer. Then of course today we're probably most likely just going to be working in normal mode and in table mode because we haven't come to stats. Stats I think is in term 4. So the first thing that I want to show you is for teachers. So as a teacher, there's a really nice shortcut for working out all of your class marks, converting your class marks to a certain value. So if, for example, we wanted to convert all of our class marks to something out of 100, right? Ashlyn, I will send you this presentation on Monday so you can browse it at your own speed and pace and click on all the links. They're all there for you. Okay, cool. So sorry, back to the teacher shortcuts. So if you wanted to convert a test, which is say out of 80 into percentages out of 100, what you would do is type in your percentage first, then press your down arrow key, and then type in the total that your test is out of. So at the top is where you are going to, and at the bottom is where you are coming from. Once you've done that and you've created your ratio, you say times and you put your first student's mark in. So say 55, right? Then we're going to say equals, and we're going to get 68 3/4, and we can change it to give us 68,75. That's your first student's mark. So that's the hardest part here. Then for your next student, say they got 40, right? So we just type in 40, we press equals, and we get 50%. The next student got 23 equals, they got 28.75%, and so on and so forth. So you can just keep typing in marks until you are finished with your entire class list. It's very, very quick. It will save you a lot of time. Your coffee will still be hot, which will be wonderful. And you'll actually get to spend time with your family, which is great. And the nice thing here is this works on all sharp calculators. So regardless of the model, so if you have English teachers who are struggling, I pick English teachers, but any other teachers that are struggling to convert their marks, this is a really helpful shortcut for them. So if you have just a basic desktop calculator, what you would do is say whatever you're going to divided by whatever you're coming from, and then press equals, and then multiply by your first mark equals, and then mark equals until you are done, and it will keep multiplying by that ratio for you. Okay, so what I try to do before we jump into just the general topics that were requested across the in the comments and questions, etc., is I looked at some of the errors that students make regularly. So I did a bit of research, looked at what other people were saying, and so these are the most common things. So obviously the first thing is that they need to read the question carefully. Often kids will skip part of the question, or they won't read it carefully and they miss an important piece of information, or they don't read it correctly and then they take the wrong information into the question. So they need to make sure that they're reading the question carefully. And to help them with that, so any students who are listening, read other things too. Read books, read the news, and particularly if you're a math lit student, read the news, because the questions that you're going to get in your exams, particularly at the end of matric, are going to be based on what's happening in the world around you at the moment, okay? And you need to be able to read critically. So whether you read whatever you read, make sure that it's a little bit more challenging for you. And this will help you to build up your language skills and to understand questions in maths as well. And if you don't understand a word, look it up. Google's got a fantastic thing where you just write the word and definition, and it will just give you a definition straight away. So it's really nice, particularly if your first language is not the language that you're writing your exam paper. Okay. Make sure that you write down your question correctly. So this is just a copying error. Be careful to check that you've written it down correctly, okay? And following on from that is rushing through the paper. So often when I was doing extra maths with students, I would actually tell them, we would work out how much a particular question was out of. Well, we would see what a particular question was out of, and we would actually work out how many minutes they had to answer that question based on the marks and the time that they were given. Okay, and this is a fantastic exercise to do with your students as well, particularly when you start doing exam revision with them. Show them how to work out how many marks or how many minutes they get per mark. And so that when they start writing or answering questions, they can see how long that time actually is. I really found it really helped my extra math students just to feel the length of that time, you know, because often what they'll do is they'll rush through a question or rush through the paper, and then they haven't answered it nicely because they think they don't have enough time, when actually they've got plenty of time. And of course, these are the students that are not going to go back and check their paper. They're going to doodle on the back. Okay, so help them to understand the concept of how much time they've got. Rather, don't rush through your paper and do the questions that you do answer really well. Okay. And then if you do struggle with a question, rather than trying to answer it right then, leave a space for it, or make a note and say, please refer to the end of the paper or something along those lines, so that your teacher knows where your answer is, firstly. And number your questions obviously correctly as well to go along with that as well. Okay, and then make sure you write down all of the steps for your working out. Okay, often what might happen is you make a mistake with a sign, but you will get follow-through marking for that. So you'll lose 1 or 2 marks, but if you've shown all your working out, your teacher can follow your logic and you can get some marks instead of no marks if you just wrote down the answer, because your answer would be wrong because one of your steps is wrong. Does that make sense? So that's that. And then, of course, pay attention to your signs. Make sure that you check them and check them again. And then remember your rules as well. And if in doubt, check on your calculator. I mean, we're all human. I still check on my calculator all the time, even though I play on the drill mode often. Less than I probably should. But yeah, so just check your signs. That's very important. And then, of course, don't divide by 0. If you try and divide by 0, then realize that x doesn't exist, and you can write. So if you have a solution where you're trying to divide by 0, you know that the answer does not exist. Okay, and pay attention to restrictions. And this is particularly important when we are talking about things with fractions. So when we are dealing with hyperbolas, for example, or when you're dealing with algebraic fractions, you need to write down your restrictions for the algebraic fractions. So if, for example, you have something over x plus 2, then x plus 2 cannot equal 0. Therefore, x cannot equal negative 2. Okay, so that would be a restriction on your algebraic fraction. Okay, for those doing grade 8 and 9 maths and math lit, pay attention to the units that you are working in. And even in calculus, when you're doing optimization questions, pay attention to the units that you're working with, okay? Make sure that they are all the same units, particularly when we're looking at something with measurements. Okay, and then of course, follow the rules of BODMAS. It's very important. It still exists in grade 12. It doesn't just fly out the window after grade 7. Okay, and remember that the O doesn't stand for of anymore. It stands for other. So for example, exponents or surds or anything along those lines as well. Okay. All right, fantastic. Let's jump into algebra. So there were 4 really common mistakes with algebra, and the first is parentheses, okay? In other words, your brackets. So be careful to apply the entire rule or whatever you are doing to the entire bracket and not just to the first part of the bracket. So for example, here we can see that the 4x was multiplied with the 3x, but not with the 7, and it should have been multiplied into both. Okay, here they squared the first number and they squared the second number, but they forgot that it's the entire bracket squared. And when we do brackets, we need to remember FOIL. Okay, so that means that you can't forget the inners and the outers, which is going to give you 42x, okay? Because it's 7 times 3 is 21, and 7 times 3 is 21, and 21 and 21 makes 42x. Okay, so just be aware of that as well. Sorry, guys, I just want to get a mouse pad here so that I can write. Okay, great, fantastic. So that's parentheses. Then, of course, substitution. Remember that 2x means 2 times x, and it doesn't mean 20 digit of x, whatever the x is. Okay, so pay attention to that. And that x squared is x times x as well. So when you substitute, it's 2 times x squared and not 2x and then all squared. Okay, that we write that differently as well. And then, of course, it's much easier when you substitute to use your brackets. Do you see the difference here? So you might forget the sign if you've done it here, but you definitely won't if you've put them in brackets. So always substitute using brackets. It will make substitution, even on your calculator, a lot easier as well. All right, fractions. So again, we were talking about that restriction. Remember, x cannot equal 0 in this fraction, okay? And then remember, you can never ever cancel over a plus or minus sign because there are 2 terms on top, okay? So you can only cancel when there's 1 term on top and 1 term at the bottom. In other words, when they're being multiplied. So here, you need to first factorize, take out a common x, and then you can cancel. Do you see the difference in your solution? Okay, remember cross-canceling only works if you are multiplying, okay? So if you are trying to divide first, obviously tip your fraction over and then multiply, okay? Now, it's very important here when we talk about equations versus expressions, okay? So an equation has 2 sides with an equal sign in the middle, okay? So in other words, something is equal to something else. It's balanced. There's a scale. Whereas an expression only has 1 side. You can only simplify an expression. You cannot solve for x, okay? So when you use an equation like the first one, you can manipulate both sides. So in other words, you can times both sides by 2 if that was something that you wanted to do. But you cannot do that to an expression. You cannot just go, okay, I don't like the way that this expression looks. It's got a fraction in it. I'm just going to multiply by 2, because that doesn't actually make sense. So just be aware of the difference of those two. Okay. So here, what I wanted to show you is, because you have a 0 in the front, what you can do is take out a common factor of 2. So I have 0 is equal to 2, and then I'm going to write down the rest of mine. Sorry, I'm being terrible. That's not correct. So here, this should be a 3 because we've taken out a 2, and that should be a 2. Now, because we have an equation, we can divide both sides by 2. So what we're left with is 0 divided by 2 is still 0. And we're left with x squared plus 3x plus 2. Whereas here on this side, because you have an expression, right, you don't have anything on the side. So you can take out the common factor. Right? But you cannot get rid of it. It still lives there. So the only thing that you can do is just finish factorizing your expression. And that's it. That's where we stop. Whereas here, if we factorize your equation, we could go one step further and we can say x plus 2 is equal to 0, because one of the brackets must be equal to 0, right? Or x plus 1 is equal to 0. And then we know that x is equal to minus 2, or x is equal to minus 1. So do you see the difference between the two? Okay. If you are a teacher, I apologize for preaching to the choir, but it's always good to remember these mistakes that are quite rife with students. Okay, then for exponents, remember when you're multiplying x's together, you are adding the exponents. Okay, so remember your exponent laws. So x times x times x is x to the power of 3. Whereas when you add x's, they're all the same. So I have 3 of these x's. Okay, so just remember the difference between those two. And then remember, same as we spoke about in algebra, when you have an exponent on the outside, it applies to the entire bracket on the inside and not just the last variable or whatever's inside that bracket. Okay, so just be aware of that. I always used to tell my extra math students that the one on the outside of the brackets is a germ, and it gets into the room, and germs are non-discriminatory. They pick on everyone, although COVID is proving me wrong at the moment, but you know what I mean. Okay, so the germs go to everyone. How they react to the germs is up to their immune system, but yes. Okay, and then of course remember, anything to the power of 0, regardless of what that anything is, raised to the power of 0 is always 1. Okay, and then make sure that you pay attention to negative exponents and how they ask you for the question. If they ask you, do not leave answers with negative exponents, or write all answers with positive exponents. It means that when you have an answer or a solution with like that, it needs to be written as 1 over x to the power of 3. Remember, this says that the girlfriend or boyfriend is grumpy and she wants to go downstairs and have some alone time. Okay, and that's why we do that. All right, cool. So then with the exponential equations, you need to know how to find your prime factors. So I just want to show you a very nice shortcut on your calculator. So if we were looking for the prime factors of 27, what we would do is just type in 27, press equals, and say second function and p fact. Okay, and then we get 3 to the power of 3. Now, we can solve that very quickly. So what we'll have is 3 to the power of x is equal to 3 to the power of 3. And so we know when the bases are the same, my exponents are equal. Okay, in other words, x is equal to 3. Okay. Right, so then of course remember your BODMAS rules, and then what I've done is I've linked these worksheets, so the grade 9 exponents worksheet and the grade 10 exponents worksheet, for you to practice. So it will give you a link where you can download both those worksheets with the memo as well. And then remember, we've just finished doing a grade 9 exponents investigation for the maths teachers. So if you're looking for an investigation, it is on Maths at Sharp. Otherwise, you're welcome to email me. I'm happy to just send it to you directly as well. Okay. Now, for a more complicated exponential equation, something like this, the first step is always to break down, especially when you have with the x plus 1 or these sorts of exponents, to break it down into its simplest form. In other words, to undo the rule of multiplication. Okay, so what we're going to do is we're just going to go backwards. We're going to say 5x and 5 to the minus 1 minus 3 times 5x times 5 to the 1 plus 10,000 is equal to 750. Okay, then we're going to take this one to the other side. And what we're going to do is here, we're going to take out a common 5 to the power of x. Okay, so we're going to have 5 to the power of x times 5 to the minus 1 minus 3 times 5 to the 1, so that's just 5, is equal to negative 9,250. Okay, now we can simplify this one because it's just numbers. So it's 1/5 minus 15. So that's going to give us 14 and 4/5, right? So I'm not going to write that down because I'm running out of space and you can see how atrociously I write. So what we're going to do is divide both of those by the 14 and 4/5, right? Remember, when you have an equation, you can divide by both sides. Sorry, negative 14 and 4/5. Okay, so what we have left over here is just 5 to the x. And on this side, we have, now I did the solution yesterday, which is why I know this answer. Okay, so don't think I'm amazing. 620. Okay, and then I'm going to lose everything here, so make sure you're happy with what I've done. I'll just give you a second while I check this question. Oh, thanks, Roselle. So Roselle has shared a link. I'm going to pop it into the chat for everybody. It helps with exponents. There you go, guys. So if anyone is interested and needs help with that. Thanks, Roselle. I appreciate that. Okay, cool. So we've all got this, right? Okay, so let's go and look up 625. So 625 is equal to, and then the second function, p fact, and it gives us 5 to the 4. Okay, so now what we've got, see what I mean by we lose everything. So now what we've got is 5x is equal to 5 to the 4. And because my bases are the same, my exponents are the same. So I can say x is equal to 4. Okay, so that's just the difference. Remember, you will get slightly more complicated ones. You might get one with 2x. Then remember that that is a trinomial factorization as well. So there's lots of different ways to factorize it. So just look out for those things. And remember, guys, practice, practice, practice. Okay, awesome. Then remember your third rules. Remember that the square root of x plus the square root of y is not the same as taking the entire square root of x plus y. And I've done that just on the side here, just, oopsie, sorry, as a proof for you. Okay, but x, square root of x times square root of y, you can multiply them together because your exponents are the same. Okay, so that's the difference because you both have a root of 2. If you had a square root of x and a cube root of x, you would not be able to multiply the two of them together. Okay. And then, of course, remember your third laws. You can only add or subtract like terms. In other words, when your thirds are the same. If they are not the same, then you cannot add them together. It's like trying to add x and y. It's not going to happen because they are different. Okay. And then, of course, if you have a square root over a square root, you can take the square root of the full thing. So that might help with simplification as well. So here's a nice example for you. What I did is I just typed each individual one into the calculator. And the reason that I did that is because if you want to show your steps, you don't want to put this into the calculator. I mean, yes, you do at the end to check that you got the answer right, but you first want to show all of your steps. So the first step is to break each of these down into their basic surd forms. Okay, so the basic surd form of square root of 48 is 4 times square root 3, right? And the basic surd form of square root 147 is 7 times square root 3. And this one over here is 11 times square root 2. Okay, now because the top two have the same types of surds, we can add the two of them together. So 4 plus 7 is 11, and then I write down my surd over 11 times square root 2. Now I have 11 and 11, so I can cancel these out. 11 divided by 11 is 1. So what I have left over is square root 3 over square root 2, which I can also write as square root 3 over 2 because the square root signs are the same. Okay. All right. Happiness and sunshine. Any questions yet? We all good? All right. Fantastic. Okay, let's move on to number patterns. So there are basically 3 types of number patterns. The first is your linear or your common difference pattern. Okay, so in other words, when you add the same thing every single time. So here we can see we've added 2 each time. Okay, so our D stands for the difference. So add 2, and our C is what we add or subtract to reach our first term. So if our difference is 2, what do we add to 2 to get to 3? We add 1. Okay, for our geometric and exponential ones, it's what we multiply or divide by each time. So here we can see we're multiplying by 3. So A is always your first term, and then R is what you're multiplying by. So if you're dividing, your R just becomes a fraction. Okay, so if we were dividing by 3, we're going in this direction, it would just be 1 over 3. Okay, so then our formula here would be 1 times 3 to the power of n. Now, a quadratic formula in grade 11 is your second common difference pattern. In other words, your first difference is a linear pattern, and your second difference is the common difference where it stays the same every time. Okay, and there's a whole thing on quadratic formulas, which we did in term 2 webinars, and I'll talk about that in a few minutes as well. Only in IEB do they expect you to rationalize the denominator, but you will get marks for either or of those methods as well. Yeah, okay. So number patterns, some important things to note. Remember that your term position starts at 1, not at 0. Okay, so you cannot ever have a negative term position. So when we are talking about solving a quadratic pattern, remember that if you get a negative answer, and for any pattern, in fact, it's that answer doesn't exist. It's not possible. Okay, so you say it doesn't apply, or NA. Okay, and then to find your C, you can also go backwards when you have a common difference. So here we have 17, 14, and 11. If we go backwards, we subtract 3. So 11 minus 3 will give me 8, and my plus C will be 8 on my pattern. Okay. Then for those in matric, sequences and series is just a very fancy way of saying number patterns, okay? And they add a little bit of formula to it. So you need to remember your formulas, learn them off by heart, remember what they stand for, and then remember again, if you have trouble remembering your formulas, that you do get a formula sheet in your exam. So don't panic, okay? But it definitely helps to learn your formulas off by heart. So I had a teacher who used to tell me, just write everything on Post-it notes and stick it around your house, okay? And stick it wherever you're going to see it, in your cupboard, on your mirror, where you brush your teeth, so that you see them all the time. And it's like learning a cell phone number. The more you see it and the more you use it, the more you will remember it, right? So same. Okay, although no one remembers cell phone numbers anymore, but I digress, okay? And then pay attention to what the question is actually asking you for. And then with sigma notation, be careful of the terms. So sometimes you might get something that looks like this, where you have I is not equal to 1, it's equal to 5, and your end term, say, is 10 or 20 or whatever. Then the number of terms between 5 and 10 is not 5, it's actually 6. So if we count, we've got term 5, term 6, term 7, term 8, term 9, term 10, right? So if I count these, it's 1, 2, 3, 4, 5, 6 different terms. So when you, and I took this as a shorter example because you might get ones where it's like 100, for example. So just be aware that when you're counting terms, particularly for sigma notation, that it is actually your end value minus your start value plus 1. Okay, and that works for a lot of term patterns, not necessarily just for sequences and series. So just be aware of that. That's one of the ways that they like to catch you out. And then they consider that a higher order question. Okay. So, happy with number patterns? All right, let's move on to trigonometry then. Okay, so with trig, remember what your trigonometry equations look like. I should have actually started with the equations, but anyway, we'll move on to this. Sorry, with the graphs, but we'll start here. Okay, so remember what your graphs look like. Remember how often they repeat. Okay, so when you're trying to solve a trigonometry equation, you always start from the point that is most far away from your angle or your x that you're solving for. And then remember that anything that is attached to your x, so say, for example, we have sine 2x, right? That's inside your sine ratio, which means that you need to deal with the sine ratio first before you can deal with the inside of your sine ratio. Okay, so just a heads up. And that works for sine, cos, tan, whatever. So any trigonometry ratio, I just like to use sine because that's the order we learned them in. Okay, and then remember your sine and your cos graphs repeat every 360. So think about the way that you're drawing those graphs, whereas a tan graph is once every 180. Okay, so there's 2 answers per 360, and in a tan graph, it's 1 answer per 180. And I'll come back to that in a sec when we start answering questions as well. So I've done a nice example here for you. I've taken it from the previous webinar that we did, but it's always good to revise and go through these things. So here we can see the furthest thing away from x that's not on the other side of the equal sign is your 3. So we're going to get rid, I say that in inverted commas, of that 3 by dividing everything by 3. Okay, so on this side, 3 divided by 3 is 1, and we're left with sine x plus 30. And on this side, we're left with 1 divided by 3, or 1/3, okay, which is what we have here. Now, this part is inside the brackets, so we're going to deal with the trig ratio first. So we find the inverse of sine, or arc sine, as it's called. Okay, so what we are doing is you just press second function sine to get to that, type in your trig ratio, and you get an angle, which is 19.47 degrees. Okay, and we call this your reference angle. Okay, so in other words, we have x plus 30 is equal to 19.47. Now, with sine, as I was saying earlier, remember how your graph looks. It goes like this, right? So if I'm looking for a specific part, if I put my ruler through, you can see there are 2 points, okay? And if we think about the cast diagram, sine is positive in the first 2 quadrants, okay? So we're going to have the first quadrant, which is just 19.47, subtracting the 30 and adding your K360 for that repetition. And then in the second quadrant, we're going to have 180 minus 19.47, and then, of course, subtracting your 30 from your original, and then adding your K360. So these are our general solutions over here. Okay. Now, what's really nice is you can shortcut your specific solution, and I want to show you this. It's really awesome. So what you do on your calculator, instead of having to substitute over and over again, we're going to go to table mode, and we're going to let the calculator do the hard work for us. Okay, so we're going to type in our 2 general solutions. Okay, and obviously we can't put in a K because we only use x in table mode. Okay, so whatever variable you're given, just substitute it with an x, and then we're going to multiply it by 360. Okay, then our second one will be our second general solution, 0.53 plus x times 360 degrees. Okay, now we've asked to find them between 30 degrees and 200 degrees. So any solutions between 30 degrees and 200 degrees. So you can see, here's my K or my, that I've substituted in, and I can see that this is nowhere near what I need. So even at 0, I don't need that. So here is my first solution, 130.53. And then here I can see I've already gone past the 2. So I'm all done. I don't need to go any further. But if they asked you for a wider range, then you know you can find it here quite easily. So that's a nice way to do it as well. There are more examples in the Term 2 webinar that we did at the beginning of the term if you want to refer back to that as well. Okay. Then for your trigonometry functions, so your basic functions such as sine, cos, and tan, learn the shape of them. Okay, learn where they start and what they're supposed to look like. Okay, then remember when you want to increase the sign of your wave, okay, so generally all of these are between, well, sine and cos fall between 1 and -1. So when you multiply it by something in the front, what it does is it takes this and it does this. Okay, so that's what A does. When you multiply your X with the B, in other words, the inside, what happens is it just creates smaller, closer together waves. So like this. Okay. If you want to shift your graph up and down, you add a specific value to it. And then if you want to shift left and right, which I'll discuss in a minute with you, you can use the X minus P value as well. All right. So what I did on the calculator is I just put the 2 graphs into function 1 and function 2 on the calculator, and I went and I plotted the points for you. So this is my first graph, which is just sine X. Okay, and I've just plotted these points on GeoGebra. You can see that it's really nice because you can change the colors. So GeoGebra is a fantastic tool for the maths teacher and for students. And then this is sine X plus 1. And you can see that the only difference between the two is that there's just 1 unit difference between every single point here. Okay. Then we've done the same thing and we've shifted left or right. Okay. So here, sorry, let me just go back. So we said X plus 30. Okay. So, sorry guys. What I want to go is back this side. Okay. So X plus 30 in my graph, okay, is equal to 0. So when I take it to the other side, it's X is equal to minus 30. In other words, I'm shifting to my left. Okay, so when it's X plus something, we shift to the left. When it's X minus 30 is equal to 0, then it's shifting to the, sorry, that's just atrocious, shifting to the right. Okay, so it's actually positive after you've solved for it. And if you look here, here's my original graph of sine X. And here's the one with the shift of 30 degrees. You can just see all that's happened is it's moved to the left by 30 degrees. Each of your points have just shifted over. Okay. Cool. All right, functions. So functions is a massive topic all on its own. So I've just quickly put together summaries for you. So we can just go through them very quickly. With your parabola, remember to pay attention to the shape of your face. And the shape, if your A is positive, then your face is a smiley face. If it's a negative, it's a sad face. And that will affect your minimum and maximum values, minimum or maximum values, your turning points. And then it will also affect your width of your parabola. So the bigger your A value is, above 1, the skinnier your parabola is, and the smaller between 0 and 1, so the fractiony side of things, the wider your parabola will be as well. Then, of course, your domain is all your possible X values. So it'll just be negative infinity to positive infinity. And your Y, depending on if it's a happy face, then it will be greater than your minimum turning point. And if it's a sad face, it will be less than your turning point. Okay, then of course, for all the intercepts, to find the x1, you make y0, and to find your y-intercept, you make x0. So I'm only going to mention that once. Your asymptotes, there are none for a parabola. You only have one axis of symmetry. So if you folded your parabola in half, it would be the point where your x turning point is. Now, there are different methods to find the turning point. So in grade 10, we are just given a formula where we are told x is equal to negative b over 2a. And that actually comes from calculus, which you'll discover in grade 12. But in grade 12, we use the derivative, and in grade 11, we use completing the square. Okay, so when you're in grade 12, you can use any of the three methods. It's up to you, whatever makes you happy. But in grade 10, you can only use this one. And grade 11, you can use either of the two here as well. So if they are not comfortable with completing the square, they can use this method as well. All right, then with your hyperbola, remember when your A is positive, your hyperbola is in quadrant 1 and quadrant 3. Okay, because positive times positive and negative times negative is positive, right? And then when it's negative, it's going to be a negative and a positive sign, like so. So it'll be in quadrants 2 and 4. And then, of course, A also decides how close to your axes you are going to get as well. Okay, again, your shift is decided by your P. From grade 11, you start using that. And then in grade 10, you use your shift up and down as well. Your domain, your range, your intercepts. And then, of course, to find your axes of symmetry, you can use this formula here. So this one comes from the Handbook and Study Guide in grade 11 by Kevin Smith. I love that textbook. It's one fantastic reference point. So this is a really nice formula to remember your axes of symmetry. It really makes things a lot easier to solve for as well. And then, of course, there are no turning points in a hyperbola because your gradient never changes signs. Okay. Okay, then, of course, your exponential graph. Remember, this is the formula for grade 11 and 12. In grade 10, you only deal with bx plus q. Okay. And then, of course, when your gradient or your A value is positive, then it stays in the top 2 quadrants. When it's negative, it stays in the bottom 2 quadrants. Then B determines the direction of your graph. So B will never, ever be negative. Because if it was negative, what would happen is you'd get this wave. Or in fact, it would start small and then just get bigger and bigger. It's really an interesting exercise to do with your students if you have time. On the calculator, get them to plot it and then ask them why it happens. But be careful of substitution and all of that sort of stuff as well. So when B is a fraction, your graph moves from big to small. Okay, so in other words, from high on the left to small on the right. And then when B is bigger than 1, so not a fraction anymore, just a whole number, then it moves from small to big. Your domain is all your possible x values, so negative infinity to positive infinity. Your range will depend on your shift of your exponential graph. And of course, remember to use prime factorization to help you solve that. With your exponential graph, you only have one asymptote, and that is your shift up and down. Okay, there are no axes of symmetry. You can't fold it anywhere along the point and find a mirror image. Okay, and then again, because there is no change in the gradients, you don't have any other turning points. So 4 important things to remember: pay attention to the shape of your graph, pay attention to your A. Even when you're looking at the picture and you don't know what your A is yet, your picture will tell you whether it should be negative or positive, and so on. And then remember, I called it the preamble in the question header, for lack of a better way of putting it. But remember to read the introduction to the question, especially for functions. It gives you so much information. Write down that information again onto your page so that you can see it, you've got it, and you know what they're talking about. Okay. And then remember that there are different ways to get to a certain point. And you should see the matric final exam paper, guys. It's got 4 different options often for one particular question on how to answer it. So find something that works for you. Obviously, that's mathematically correct. And I say this with factorizing as well. Find the thing that works for you when you're factorizing a trinomial or whatever, and use that thing. As long as it's mathematically correct, it's great. Okay, so sometimes the way that one person explains it to you doesn't make sense, but if you go and look in another textbook or you find another reference for it, it does make sense in that way. We all think differently, so we respond to things differently. And again, remember to practice, especially functions, because there are lots of things that can catch you out. So pay attention to your theory. Okay, remember what those quick summaries that I've done. That just needs to be a quick, you must be like, oh yes, of course I know that. Okay. What I've done is I've actually linked the section on functions for all of the worksheets from grade 8 to 12 for all topics, maths and technical maths here. So if you click on that link, you can just scroll through all the various worksheets and find the one that works for your grade. Okay. Then finance. Let me just see how we're doing. Oh, sorry, guys. So we're nearly done. So with finance, look at your simple interest. Simple and compound interest is just adding, and then with decay is just subtracting. So same formula, just substitute A minus. Okay, and then always write down your pain. Okay, so I say use your pain, PAIN. So for initial, final amounts, your interest, and your number of intervals. Okay, and then pay attention to your intervals. Did they tell you that it's compounded monthly and then they gave you a number of months, or did they tell you it's compounded annually and give you a number of years or whatever? Make sure that you write down that information and pay attention to the information that they give you. Okay, and then remember for timelines to work through the questions step by step. And as you're working through the information that they've given you, write it all down on your timeline as you go. Okay, so sort of draw your timeline in and then say, okay, I initially invested so much, and then at the end I had so much, but I got this interest rate here, and this took me how long here? Because what's going to happen is it's going to create a flow. So you're going to get enough information to solve the entire thing. You just need to figure out what's missing. And maybe for each of these periods, write your pain sections down so that you can see what's missing in each of them. And it will help you solve and figure out what belongs to what. Okay. With timelines, again, it's also about a practice thing. Okay, so I wanted to show you something really cool with the present value annuity. Remember matrix, again, you have the formula sheet. Yes, it's good to remember the formula, but I must be honest with you, I still can't remember it, and I work with it quite regularly. So try and learn it, but if you can't remember, it is on the formula sheet, and particularly for present and future value annuities, go and check what you've written down, because they are so similar, the two of them, that it's easy to make a mistake when you've got a present and a future value. Remember, a present value is you are borrowing money right now and you are paying it back. A future value means you are putting money in now and you're going to get paid back later in the future. That's why it's called a future value. Okay, so future value we use for things like retirement funds. Present values we use for things like loans on a bond or a car. Okay, now I wanted to show you this because it's really, really cool. We did do it in the Term 2 webinar, but just as a refresher. So what I'm going to do is I'm going to type in my formula for the present value annuity, and I'm not going to put in a payment value. I'm going to type in an X instead. Okay, so 1 minus 1 plus, and then I have 10% compounded monthly. Oopsie, sorry, that needs to go there. And then I'm going to borrow it over 5 years, and I'm going to pay it every month. And then my interest rate again is 10%, oopsie, compounded monthly. Okay, so that's the formula. Here, let me just get rid of that other one, and then let's go through. Now, what's happened is I've actually said if I can pay back R2 a month over 5 years, I can borrow 94 Rand. Okay, so this doesn't really help me. This is a little bit small. So what we're going to do is we're just going to change our step to say 200 Rand. Okay, so we're going to jump in 200s. So if I can pay back 200 Rand a month over 5 years, then I can borrow 9,400 Rand. If I'm willing to pay back 1,000 Rand a month, then I can borrow 47,000 Rand. If I can pay back 2,000 Rand a month, then I can borrow 94,000 Rand. Okay, so that's just the difference. This is often how they'll calculate your car affordability. Okay, so this is where your car repayments come from. So if you can pay 3,000 Rand a month, then you can buy a car worth approximately 140,000 Rand. Give or take a few cents. Okay, so go and explore that. It's really interesting. And also what's nice here, and let me come back to this here, is if you say, for example, had a present value, which was 200,000 Rand, okay? And you wanted to find out how long it would take you to pay that off, okay? Then you can put it in here. So I'm going to leave my steps here, and you can see every month I've paid, okay, so 1 month I've paid back that. So this is how, sorry, I've done something funny. Yeah, there was something, oh yes, we're looking for what it would take to pay back 200,000 Rand a monthly. Your monthly fee would be approximately 4,300 Rand. So if we go and change our start to 4,000, right, and we make our step 100, okay, then here you can see we would pay approximately between 4,200 Rand and 4,300 Rand a month. Okay, so it's a nice way to check that you've got the correct value for your principal amount as well. Okay, cool. The last thing that we want to discuss today is calculus. Okay, so first things first, learn your rules, learn them off by heart, especially if you're going to go and study anything with maths in university. You want to do a lot of calculus, trust me. So just learn these rules. They will stand you in good stead for a long time. Okay, and then remember always to multiply out. You cannot take the derivative of this one without first multiplying out. I'll come back to this in a sec as well. And then, of course, all of your worksheets are here for calculus, so including optimization, first principles, etc. as well. Then remember again, make sure you multiply out your brackets before you try and differentiate. You need to have individual terms, especially when you have exponents like that, before you can differentiate. Okay, and then always make sure that you do not have an x in your denominator. So bring your x to the top, make it negative before you try and differentiate. Okay, cool. So in summary, you can watch the first and second term webinars on our Maths at Sharp YouTube channel. Here is the link for you. So that will depend on whether you are grade 10 to 12 or grade 7 to 9. Grade 10 to 12 for term 2, there were 2 webinars, so just be aware of that. Part 2 is more grade 12 work, and part 1 is more grade 10 and 11 work. Okay, and then remember to practice. So if you need worksheets, email me, ask me for them. I'm very happy to send them to you. I do believe in practice. Maths is a practice subject. Okay. Remember that you can't study maths the way that you do study other subjects. It's not like history or English where you can sit down, draw your notes, write down your notes, and then think that that's finished. Yes, you must write down notes and study your theory, but you also need to be able to understand your theory and then apply your theory to the questions. Remember, you're not going to get asked theory questions. Well, you're going to get asked very rarely a theory question. 90% of the time, you're going to get asked to apply your theory in your exam paper. Okay, now this article here from Learn with Confidence is written for mothers to help their primary school students, but it's got some really nice tips in it. So you're old enough to help yourself study. So it's a really helpful, and a lot of it will help anyway with your studying as well. All right. Thank you guys so much for joining me today. I hope that you found this useful and exciting. And if you do have any questions, you know where to find me.